All right, we're going to work with drawing angles in standard position. So we're going to start with radian measure. So 3/4 of a revolution around the coordinate plane looks like this. And the angle is 3 pi over 2. Remember, the full revolution around the coordinate plane equals 2 pi radians. So we went 3/4 of the way around. So 3/4 times 2 pi is 3 pi over 2. Second example, halfway around. So we start here, we go halfway around the coordinate plane, and we stop and we create that angle measure. Well, halfway around the coordinate plane, 1/2 of 2 times pi is pi radians. So this is the angle measure, pi. The last one is 1/4 of the revolution around. So here's our initial, here's our terminal. We're going 1/4 of the way. So 1/4 of 2 pi, this angle right here is pi over 2 radians. All right, continuing on. We're going to draw and label each of these angles in standard position. So here's our first example, theta. Theta is a Greek letter, equals pi over 4. So we always start in our standard position. It is a positive angle, so we're going to go in a counterclockwise direction. Well, if we look back, here is pi over 2, and we're going to split that angle in half to give us pi over 4. So here would have been pi over 2, but we're going to split it in half. So here is our angle of theta. So let me erase that because I should put that in green. And that's pi over 4 radians. Next example. We want to graph alpha equals 5 pi over 4. So we start in our standard position and we start to count. Here is pi over 4. Here would be another pi over 4, or 2 pi over 4, which remember is equivalent to pi over 2. Add another pi over 4, which would be 3 pi over 4. Then go to 4 pi over 4, which reduces to pi, and then one more quarter around, 5 pi over 4. So I'm going to erase this green here, and I'm going to change this to blue. So here is our initial position, here is our terminal, and then we show the direction that we're going in a counterclockwise direction. So there is our angle alpha of 5 pi over 4 radians. All right, we're going to now graph beta, -3 pi over 4. So we're going to be going in a clockwise direction. Here's your terminal, or sorry, your initial side. We're going to go down -2 pi over 4, another -2 pi over 4, which is -2 pi over 4, and then another -pi over 4, which is -3 pi over 4. So now I'm going to change colors. Our angle beta, here is our initial side, there is our terminal side, and we do need to show the direction that the angle is going, and this is our angle beta, -3 pi over 4. D, 9 pi over 4, we're getting bigger. So we're going to just go ahead and start to count. So we have to count, here it'd be pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6, 7, 8, and 9. So we're ending up right there. So to be able to create this angle gamma, we start with our initial side. We run around 1 full revolution, and then we're going to stop at that terminal side. So I'm going to go ahead and just create that first revolution and then stopping there, showing the direction. Here is a figure showing the degree and radian measures of angles that will be seen in trigonometry in our later lessons. Notice this is your degree measure, and these are your radian measure and degree measure, one going in a positive and one going in a negative direction. So these angles are going in that positive direction, these are going into a negative direction, and what you're seeing is the equivalent. So 30 degrees is equivalent to pi over 6. 45 degrees is equivalent to pi over 4. 60 degrees is pi over 3. 90 degrees is pi over 2, etc. You can see all of those equivalent angles. If we go in the negative direction, negative 30 degrees equals negative pi over 6, and you can continue seeing those equivalent angles. We also have the terminal side and how many revolutions that it is around, so from 1/12 up to 1 revolution, and its equivalent radian measure and degree measure. So go ahead and pause and look at those equivalent measures, and then we'll